So we're going to take this problem into three parts, and we're going to make three videos out of this to explain z-scores and how we use z-scores to figure out probability, and in this situation to understand the performance of the company. So let's look at this question here. It says a company makes a mean monthly income of $20,300 and a standard deviation of $3,200. And in one given month, the company makes this much, $29,500. So that's their performance for 1 month. So let's go ahead and label these. This is going to be my mean or my mu. This is my standard deviation. And then this is the performance, which we're going to call X, our data, for one given month. And part A says to find the z-score. So we want to know, well, how did they do this month compared to their average performance? So if we look at our normal distribution bell curve here, first of all, we want to know, well, why do we use z-scores? Right? So if we come down and we look at this distribution, we see that our mu is our 20,300, and then if we apply our standard deviation, we go one standard deviation above that, it's going to be 23,500, and so forth, and we continue to plot along until we have three standard deviations above would be 29,900. Well, if the company made 29,900 exactly, we would know that that's three standard deviations above, and using our empirical rule, as we break this down, we know that the area under the curve between one standard deviation below and one standard deviation above, all of this area in here under this curve represents 68% of the data. So as we break that down, we know between two standard deviations, the area under the curve is 95%, and then 99.7% between three standard deviations, leaving us with this 0.15% out here beyond three standard deviations. So we would know if for example, they made 29,900 exactly, we would know that 0.15% of the time it is likely that they would make above what they made in 29,900. And usually the case is for 99.85% of the time, they're going to make less than that. So their performance there that month was extremely good. However, we see the data here. We see that their data was 29,500, which is going to be somewhere in between. It's going to be somewhere in between two standard deviations and three standard deviations. And when it's not right on the standard deviation, we need to use a z-score to tell us, well, how likely is that to happen, and how much, what percent of the time do they make less than this, and what percent of the time do they make more than this? So our z-score formula is z-score is equal to the data for that month minus the mean that they normally make on average in a given year, and divide that by the standard deviation. So for this particular example, it's just going to be 29,500, subtract out the 20,300, that is our mean, and divide the standard deviation of 3,200. And when we simplify that, we're left with approximately 2.88. So this z-score, 2.88, means that it's about 2.88 standard deviations above the mean, which is where we see we go one standard deviation above, two standard deviations above, and then in between 2 and 3 about 0.2 2.88 is where we will find this particular performance. And then we can apply this 2.88 z-score and look it up on our z-score table in order to understand, well, assuming the company's monthly income is normal, what percent of the time does the company make more or less than this? So this is when we would go to our z-score table, and if we have a z-score of 2.88, then we're looking for the intersection of 2.8 and 0.08 to give us our z-score. So we come down to 2.8 and over to 0.08, and we find where they intersect, which is here. So it says 0.9980. And if we turn that into a percentage, that is 99.80%. Meaning that 99.8% of the time, the company is going to perform worse than this, bring in less income. And only 0.2% of the time will they score higher than this or bring in more income. So as we go back and say, well, what percent of the time does the company make more than this? Well, only 0.2% of the time, and less, that would be 99.8% of the time.